All right, Mr. Ahmed here for 11.5, volumes of prisms and cylinders. So with our supplemental video, taking a look at the surface area of prisms and cylinders, volume's a little bit different. Volume is the amount of space that something takes up, and the volume's gonna be cubed based off of our units. And with a cylinder and a prism, the main thing that we really have to keep in mind is what is the base. The base is not always what the figure is sitting on, all right? The base has to be a pair of opposite sides that are congruent and parallel, so opposite faces. So we'll run into a few where the piece that it's sitting on is not the base, all right? So to find the volume, the formula for the volume of a prism or a cylinder is capital B, H. And the key here, capital B, is actually the area of the base. And with a cylinder, that's pretty straightforward because the area of the base is always a circle. With a prism, the base could be a pentagon, could be a hexagon, could be a trapezoid, could be a triangle. It really could be about any polygon. And H is the height. Looks like we're using capital H. Height of the prism / cylinder. Okay, now the height is the distance between the two bases. So in our couple examples here, in this prism, all the faces are rectangles. I mean, the lateral faces are all rectangles. We didn't go over that as much as I have in the past. We kind of skipped over that due to time. So the bases in this case are both pentagons. We have a pentagon on top, pentagon on the bottom. Those two sides are opposite and parallel and congruent. So that makes it a pentagonal prism. The height is the distance between those two pentagons. In this case, we have a rectangular prism. Now, in this problem, it's a little bit tricky. The base could be the top and the bottom rectangles, it could be the front and the back, or it could be the left and the right. You really can pick that no matter what. The reason why, the top face and the bottom face are both parallel and congruent, so that could be the base. The left and the right rectangles are opposite, parallel, and congruent, so those two could be the base. So if I were using the left and the right side as the base, the height would be this distance from left to right. And with a cylinder, the base is always a circle. So the volume of a cylinder, I'm going to write this down, is equal to pi r squared times the height. The reason why it's pi r squared is because the area of the circle is pi r squared. So that's the area of the base, capital B. So I'll hop into a few examples now. A little bit of terminology is definitely helpful for these problems. We're going to look at a right triangular prism. Now, the volume is what we're looking for. That's equal to the area of the base times the height. Now, the problem is the base is not what it's sitting on in this problem because the base is a rectangle, but it's not parallel to another rectangle. It's not congruent to another rectangle. So the base is actually the triangle. That's why it's called a triangular prism. These two triangles are opposite, parallel, and congruent. So the area of the base is equal to the area of the triangle, 1/2 times 3 times 1. And the height is the distance between these two triangles, 2. Okay, the height is equal to 2. Now, I'm going to substitute this in. 1/2 times 3 times 1 is 1.5. So the area of the base is 1.5. The height is still 2. And now we just need to substitute these values in. Area of the base, 1.5, times the height of the prism, 2. The volume is equal to 3 feet cubed. Volume is units cubed. Our next one involves a cylinder. So like we said, the volume of a cylinder is still equal to the area of the base times the height. In this case, the area of the base is a circle, so we're going to do pi r squared times the height. Our height is 6, our radius is 5. Substituting it in, pi times the radius, which is 5 in parentheses squared times the height, 6. Now you got to be careful here. Make sure you follow the order of operations. 5 squared is 25, and 25 times 6 is 150. So we have 150 pi. Use your pi button on your calculator, and we will get our decimal approximation. We'll round to 2. It's 471.238. 471.238. Since it's a 3/8, I'll round it to 24, and we're in meters cubed. Found the volume of our cylinder. These numbers will get pretty large. And our next example, find the volume of the cylinder with the piece cut out. Now, in this case, I have a big cylinder and a little cylinder. All right, so I'm gonna have to take the big cylinder, I'm gonna abbreviate cylinder, CYL, minus the small cylinder. So the volume of the big one, pi r squared times the height, pi. Radius of the big one is 3. The height, distance between the two bases, is 7. Minus the small one, pi. Radius squared, radius of the small one's 1. Times the height of that one's also 7. So when we simplify this down, 3 squared is 9. 9 times 7 is 63, so 63 pi minus 1 squared is 1 times 7, 7 pi. Now you could type it into your calculator just like that, but those are also like terms, so I could combine them. And when I do, I get 56 pi. And a decimal approximation for 56 pi is 175.929. So since it's 929, I'd have to round this 2 up to a 3, 175.93 millimeters cubed is our volume. And lastly, we're looking at an oblique cylinder. An oblique cylinder is tilted, all right? Now, we don't really find the surface area of oblique cylinders in this course. However, we will find the volume. And the formula doesn't change. It's kind of like the Leaning Tower of Pisa in Italy, I believe. It's just leaned over. The volume would be the same if it was going straight up and down. The key here is the height has to be at a right angle. The height, the distance between the two bases, has to be at a 90. Okay. If it's over here with this piece on the side, you might have to use Pythagorean's theorem to find the regular height. We won't do that this year, but you may run across it at some point in time. So, volume of the cylinder equals pi r squared times the height. Radius is 4. Height, distance between two bases, is 7. 4 squared is 16. 16 times 7 is 112 pi as a decimal approximation. If we type that in, we would get right at about 351.858, so 86 centimeters cubed is our volume. And that is it for the volume of prisms and cylinders. The most difficult piece is going to be the prisms. Make sure you use the correct base. Okay, identify the base first. Area of the base times the height. Have a great day.